everyone. Today in this class we are going to discuss about linear programming solved by Simplex method. We will discuss Simplex method. We have already discussed graphical method, and graphical method is applicable when only two variables are there. So if more than two variables are there, then we can go for Simplex method. And Simplex method is developed by Professor George B. Danjik. Actually, if the number of variables is more than 2, then we can solve it by Simplex method. Here we have to take two variables. One is a slack variable. If the constraints are in less than equal to form, we use slack variable. When the constraints is greater than equal to sign, then we can go for using surplus variable. First we will discuss about, we will take one example and discuss how we can take a slack variable and solve the problem. So I have taken one example here, maximization. It is a maximization case. In next class we can discuss about a minimization case. So maximization, maximize z equal to 4x1 plus 10x2. It is an objective function. Subject to the constraints, these are our constraints. Subject to the constraints 2x1 plus x2 less than equal to 10, 2x1 plus 5x2 less than equal to 20, 2x1 plus 3x2 less than equal to 18. As it is a maximization case, all the constraints are in less than equal to form. x1, x2 greater than equal to 0. So first, what we need to do, we need to find the initial basic feasible solution. For that case, what we need to do, we need to convert. First step of Simplex method is that we have to convert these constraints into equality. We have to convert the constraint into equality. As it is in a less than equal to form, so we can go for using slack variable. Let us use slack variable and first find the initial basic feasible solution. So to find initial basic feasible solution, convert the constant into equation, that is 2x1 plus x2 plus s1 equal to 10. See, we are using the slack variable to make the constraints into equality. As this is in less than equal to form, so we are adding a positive number to the left hand side of this equation to make it equality. As it is in less than equal to form, so we are adding to the left hand side a small value, that is called our slack variable, to make it equality. Now we can do same for the next equation, 2x1 plus 5x2 plus s2 equal to 20. Now here also we can do the same thing, 2x1 plus 3x2 plus s3 equal to 18. Okay. Then what is our next step? Our next step, that these are called the, what we have taken here, these are called the basic variables. So what are the non-basic variables? Non-basic variables are x1 and x2. So assume the non-basic variables x1 and x2 equal to 0. So if we take x1 and x2 equal to 0, then what will be our s1? Put 0 here, then s1 equal to 10. s2 equal to 20. s3 equal to our initial basic feasible solution. Initial basic feasible solution. Now we can go for the optimality test. We got our basic feasible solution. We can move towards the optimality test. For that we have to draw the simplex table. How we are going to draw the simplex table and do the solution? We'll see. The thing is that here S1 equal to 10, S2 equal to 20 and S3 equal to 18. Let us draw the simplex table. As we are adding here three slack variables, so how we are going to write our objective function? Our objective function that z maximum, z max equal to 4x1 plus 10x2 plus 0s1. As we are taking these slack variables, but the cost associated with the objective function or the profit associated with the objective function will be 0, because this will not going to add anything to the objective function. So we need to take it as 0. So 0s1, 0s2 and 0s3. So next, draw the simplex table. So I have done the initial simplex table here. So what we need to write? Initial simplex table. First we need to, in the first column, we need to have the coefficient of basic variables, that is CB. Then our basis, that the new variables we have introduced, that is the slack variables. And these are our variables for the objective function. I have written here x1, x2, s1, s2, s3, whatever they are in the objective function, we have to write all the variables. Here the value what we have got in our initial basic feasible solution, that is 10, 20 and 18. As we have assumed x1 and x2 equal to 0, then our s1 equal to 10, s2 equal to 20, s3 equal to 18. That value I have written here. Then you have to calculate the maximization z value we need to calculate here. And then we have to subtract Cj, the coefficients, minus the Zj. Cj is the, here we have written all the coefficient of the, that is we can say the cost or profit of the this our Z objective function. These are the coefficients. So what we have written here? 4, 10, 0, 0, 0. So what is the rule to do the simplex table? And here I have written the basis. So for S1, the coefficient I have written 0, 0 and 0, as we have here 0, 0 and 0. Right? These are the bases. I have written x1, x2, s1, s2, s3. So whatever there in the constraint, 2, this is 2 for x1 for the first equation, 2, second the coefficient is 1, third for s1 it is 1, and we don't have in our equation s2 and s3, so I have written 0, 0 here. For the second equation, here the coefficient is 2, for x1, 2, for x2 it is 5, for s2 it is 1, for s1 it is 0, for s3 it is 0. Like for the third equation, the coefficient for x1 is 2, the coefficient for x2 is 3, s1 and s2 both 0 here, s3 we have, so I have written 1 here. We are done with the table. Now we will do the calculation of the Zj. So how we need to do the, this is in the matrix form, how we need to calculate. So 0 plus 2, you can calculate 0 into 2 That z we have need to calculate. Z, what we need to do? 0 into 2 plus 0 into 2 plus 0 into 2. So we have 0 here. That is cv into x1. cv into x1, like 0 into 2 plus 0 into 2 plus 0 into 2. Here same, 0 into 1 plus 0 into 5 plus 0 into 3 plus 0. Again here 0 into 1, 0, 0 into 0, 0, 0 into 0, 0. So all the things will get 0 here. What is the value? 10 into 0, 0, 20 into 0, 0 plus 18 into 0, 0. What is Cj minus Jj? Cj 4, 4 minus 0, 4, 10 minus 0, 10, then 0, 0, 0. Right? So what I need to do? See, what is the here? Our main thing is we have to identify Cj minus Zj. If the Cj minus Zj value for a maximization case is less than equal to 0, then we will get the optimal solution. If, once again I am telling, if Cj minus Zj is less than equal to 0, then we can get the optimal solution. So all the Cj minus Zj value here we should have in negative or 0 form. As it is less than equal to 0, we get the optimal solution. But here we are getting all positive and 0. So what we need to do for maximization case, we have to assume the most positive number here. If you see, the most positive number here is 10. Right? Most positive number is 10. So this variable, this is called the entering variable. Entering variable. So, and this column is called the key column. This column is called the key column. This column is called the key column. This is the entering variable. This column is the key column. So what we need to do? We need to then find the minimum ratio. For finding minimum ratio, what we need to do? We need to do 10 divided by 1. Ratio, the value divided by 1. That is 10 divided by 1, 10. Second, 20 divided by 5. That is 20 divided by 5 is 4. Then this is 18 divided by 3. 18 divided by 3 is 6. So this is our entering variable. This column is called key column, and we have to make the ratio of this value to the key column, like 10 divided by 1, that is 10, 20 divided by 5, 4, 18 divided by 3, 6. So what is our next? We have to see the minimum ratio here. If you see, the minimum is 4. This is 4. So this is called, this row is called the, this is key column, this row is called the key row. This is key column and this is key row. The intersection of key column and key row is called the key element. Is called the key element. So this is now our entering variable is x2, because this is entering most positive number, and the leaving variable is s2. S2 is the leaving variable. Means in our next table, S2 will leave the table, and in place of S2, X2 will enter the table. In our next operation, that S2 will leave the table, and in place of S2 we are going to have X2 as our variable. So let us go for the next table. This is our second simplex table. This is the second iteration, we can say. So what do we need to do? In our previous table, we have identified our key element. So in this table, we have to make the key element 1 and the other two value of the row, that we have to make it 0. Means the key element we have to make 0. Key element we have to make 1, and the corresponding rows which we are having in our matrix, that we have to make it 0. So what we need to do? Let us see. First we have to make the key element is 1. So to make the key element 1, in our previous table, what we are having? We are having, that is in the second row. That is the second row. So what we need to do? That row operation we need to do. That is, this is our R2 new. For the new matrix, this is our new table. So what we need to do? That is equal to R2 old. What we are having in our previous table, divided by the key element. As we know, our key element is 5. So 5 divided by 5 equal to 1. Our key element is 5. So we can divide it R2 old in our, that this here we are having 5. So we can do it, that R2 old divided by 5 or R2 old divided by key element, because our key element is also 5. So we can write R2 old divided by 5 to make this key element 1. So let us make the key element 1. But that whatever we'll do to make the key element 1, that application will be applied for the whole row. So the whole row we need to divide it by 5. So what do we need to do? In our previous table, here we are having 2. So this becomes 2 by 5. Then the value is 5. So 5 divided by 5 is 1. Then we are having the value 0. 0 divided by 5. We will have 0 here. Then we are having 1. 1 divided by 5. Then we are having 0. 0 divided by 5. 0. So now we are here. We are having 20. 20 divided by 5. We can make it 4. Like this we will apply to the whole row. Always refer to the previous table while doing the row operation. So first we need to do the key element 1. And all other row, these two, upper and lower, to the key element we need to make it 0. I am repeating once again, we have to make the key element 1 and the upper and lower row value of this column. The column of this, what we are identified as the key column, the upper value and the lower value of the key column will be 0. So what we need to do? We need to make this one 0 and this one 0. So for that we need to apply the operation to the whole, or apply the formula to the whole row. What do we need to do? To make it 0, see what we are having in our previous table. We are having the value 1. We are having the value 1 here. So what do we need to, in old table we are having value 1. So what do we need to do? We need to write R1 new equal to R1 old minus. This is R1 old means we are having 1 here. If we subtract our R2 new means this value, then 1 minus 1 will be having here 0. Let us apply this to whole table. See the previous table what we are having? We are having 2 here. So 2 minus 2 by 5 we can do here. First we will make this one as 0. In our previous table, first initial table we are having 1 here. So 1 minus 1, 0. Then here we are having 2. 2 minus 2 by 5. 2 minus 2 by 5 means 10 minus 2 by 5, that is 8 by 5. Right? Then we have done 0 here. Then same thing in the previous table, you see what we are having. We are having 1 here. 1 minus 0 will get 1 here. Then we are having 0. 0 minus 1 by 5, that is minus 1 by 5. Then we are having 0. 0 minus 0, 0. Here we are having in our previous table 10. 10 minus 4, that is 6. Right? The same thing will apply for this row to make it 0. So, if we see the table, we are having 3 here. We are having 3 here in our previous table. Please check the previous table that we are having the value 3 here. So, we need to make this 3 to 0. How we are going to make? We can make or we can write R3 new equal to R3 R3 old minus R3 old. R3 old we are having 3 here. So 3 minus 3 into R2 new. R2 new we are having 1 here. So if you multiply 3 into R2 new, then we'll have 3 here. 3 minus 3, we can say it is 0. So see, this one is 0. Means we are having 3. 3 minus 3 into R2 new. R2 new is 1. 3 into 1, 3. 3 minus 3, 0. So let us apply this to whole row. What we are having in our previous table? We are having previous table 2. So 2 minus 2 by 5. So this will be 2 minus 3 into 2 by 5. 2 minus 3 into 2 by 5. This is equal to 2 minus 6 by 5. That is 10 minus 6 by 5. That is 4 by 5. You can write 4 by 5 here. Then this is 0 we got. The next value you can calculate that in our previous table we are having here 0. So 0 minus 3 into 0, that is 0. Then what we have? In our previous table this value is also 0. So 0 minus 3 into 1 by 5. 0 minus 3 into 1 by 5 means minus 3 by 5. Then in our previous table, this one 1 we are having 1 minus this is 0. 1 minus 3 into 0, 1. Here we are having in our previous table the value was 18. So 18 minus, what will be this? 18 minus 3 into 4. that is 18 minus 12 equal to 6. So we'll get 6 here. Now we'll calculate this is very important for this row operation. So first we need to understand how we can make our key element 0 and the corresponding values of the key. This is key element, this is our key column. The key column, the key element will be 1 and the other two values will be 0, and that row operation will be applicable to the whole row. So what do we need to calculate here? We need to calculate the j value here. So 0 into 8 by 5, that is 0, plus 10 into 2 by 5, that is 20 by 5 equal to 4. 20, this is 10 into 2, 20 divided by 5 equal to 4, and this is 0. So we can write 4 here. Again 0 into 0, 0, 10 into 1, 10, 0 into 0, 0. So the value will be 10 here. Now 0 into 1, 0, 10 into 0, 0, plus 0 into 0, 0. So this is 0. How we are calculating this is, means suppose I am doing this into this, means CV into x1. So 0 into 8 by 5 plus 10 into 2 by 5 plus 0 into 4 by 5, which equal to, this is 0 plus 20 by 5 plus 0, like this is 4. So this should be applied for the whole. Means this into this plus this into this plus this into this. Again 10, 0 into minus 1 by 5 is 0, 10 into 1 by 5, this is 10 by 5, that is 2, 10 by 5, that is 2, this is 0 into 0. Then this one 0, this is plus 0, plus 0, 0. And this is 6 into 0, 0 plus 10 into 4, 40 plus 6 into 0, 0. So this is 40. Now calculate the Cj minus Cj. 4 minus 4, 0. 10 minus 10, 0. 0 minus 0, 0. 0 minus 2, minus 2, 0. So if we can see here, the Cj minus Zj value is now less than equal to 0. So this is our optimal solution. The optimal solution, that is Z maximum, is, we can say Z maximum at x2 equal to, what is x2 equal to, this is 4. So how we can write? We can write here, that is the value of Z maximum equal to 40 at the value of x2 equal to 4 and x1 equal to 0. x2 equal to 4 and x1 equal to 0. Let us put these two values to the Z max. Z max equal to 4 into x1, 4 into x1 0 plus 10 into x2, 10 into x2 is 4, which is equal to 40. So this is our Z maximum. Z maximum equal to 40. So this is the optimal solution of the simplex method. So for this, here we have x2 only. So x2 is 4 here. There is no x1. So x1 we have considered 0 because there is no x1 value here. We are getting the objective function. So x2 equal to 4 and x1 equal to 0. We have put the value to the z max here. So z max equal to 4 into 0 plus 10 into 4, that is 40, and we got the value in our simplex table also 40. So this is the solution of the maximization case of simplex method. In our next class, we will take one example how we are going to solve it by minimization problem. I hope you like the video. If you like it, please don't forget to subscribe the channel and share with your friends. Thank you so much.